Hello all, welcome to VJD Academy. This is Anil Kumar, Faculty of Digital Electronics. Sir, today I would like to introduce one more new concept called switching circuits. In the previous lecture, we have seen what are the truth tables of Boolean algebra and what is the order of minimization and what are the possible number of truth tables and what are the Venn diagrams we have seen. And now let us try to understand what are the possible number of switching circuits, or we can say that how a switch circuit is acting as a NOT gate, how a switch circuit is acting as AND gate, OR gate. Let us try to understand. Sir, here we have seen, we are going to see what switching circuits. Now let me consider the first case as switching circuit as acting as NOT gate. As NOT gate. Let us try to analyze how a switching circuit is acting as NOT gate. So let us try to take the first case, how a switching circuit is acting as a NOT gate. We know, sir, here the NOT gate means it is a complement gate. We can say that whatever we are applying input 0, here we can say we know the truth table of NOT gate. Here this is NOT gate. When we apply a equal to 0 and then 1, we may get output. We can say that output, when we apply 0 we will get 1, and then when we apply 1 we will get 0 as output. This is what analysis of NOT gate. Now let us try to understand how this NOT gate action is possible with the help of switching circuit. Sir, here this is a switch circuit. Let us try to take here, this is a switch circuit. Let me take here one switch here, and now I want to connect one bulb here, so that we will understand how this switch circuit is acting as NOT gate. Let me connect here ground. This is a switch. We will apply 5 volts power supply, and now this is a input, we can say A switch circuit, and now here we will take output Y, and now this is a bulb. This is a bulb. Sir, the moment when we apply input A equal to 0, here A equal to 0, what is happening? The moment when we apply input A equal to 0, what is the condition of Y? And now let us try to understand what is the condition of Y. Let me draw here one more truth table. Here the input A, and now what is the power supply, we can say, and now what is the condition of switch, and what is the output Y, and what is the condition of bulb. Now let me try to explain with this particular truth table. Let us try to understand. Sir, here when I apply A equal to 0, what will happen? The moment when I apply A equal to 0, the switch will be automatically opens. There is no connection between here switch and then ground. Here switch and then ground, there is no connection, because when we are apply A equal to 0, switch will be off state. Switch will be off state, or we can say that here the switch will be open, I can say. Instead of off, I can say open, I can say. And now the moment when switch is open, suppose here when we apply 5 volts, sir, here there is no connection between here this node and this node, which means there is no connection between these two nodes. So, sir, that means there is no possibility that this 5 volts power supply will go to ground. So this 5 volts power supply will go to Y automatically, which means output, we can say we will get output Y as 1. And now after this power supply will come to through here to this bulb, so that bulb will be automatically closed, or we can say bulb will be turned on. And now let us try to understand the second case here. The moment when we apply A equal to 1, what will happen, sir? Here the moment when we apply A equal to 1, here automatically there is a connection will establish between this node and then this node, which means here the switch will be connected. Here the switch will be connected. We can say that here the switch will be closed. Then the moment when we apply 5 volts power supply, automatically, because there is a connection between these two nodes, we can say from this node to ground there is a connection. So what will happen, sir? This 5 volts, entire 5 volts power supply will go to ground, and there is no power supply to to the output, we can say that output will be 0. We can say output will be 0. And now because there is no power to the output, we can say that bulb will be automatically turns off. Bulb will be automatically turns off. This is how to understand. Sir, this is the truth table. Here when we apply 0, automatically output is 1 because the switch is open and then bulb is turns on. And then here when we apply input is 1, here the output is 0 because the switch is closed and then bulb is off. Is this not a truth table of NOT gate? Yes sir. We can say that here the switching circuit is acting as a NOT gate. And now let us try to understand how a switching circuit is acting as AND gate. Sir, now let us try to understand how a switching circuit is acting as AND gate. Here I would like to take AND gate second case as AND gate. Let me take one switch circuit here with a 5 volts power supply. Sir, here I would like to take 2 input. We know that AND gate is having 2 input variables. So I would like to take here 2 switches. This is what first switch, and then let me take one more switch here. This is second switch. And now I would like to connect, I would like to take output Y, and here I would like to place one bulb. Here we will connect ground. Sir, here this is A and then this is B. Here 5 volts power supply and then this is output. Here we can say bulb. Now let us try to understand how this circuit, switch circuit, can act as a AND gate. We know that AND gate A, B, we can say Y, 0, 0, 0, 1, 1, 0, 1, 1. Here we will get 0, 0, 0, 1 for AND gate case. Sir, we know the truth logic gate expression for AND gate is this. Now let us try to understand with the help of this switch circuit how this truth table is possible. Sir, here what are the input variables? Here we can say that A and then B are the input variables. And now we can say what is the switch position? Yes, here we can say S1, which means switch 1, and then let me take here S2, switch 2. And now here we can say that what is the output Y and what is the condition of bulb. Let us try to understand. Sir, here the moment when we take 2 input variables which are 0, 0, 0, 1 and then 1, 0 and finally 1, 1, what is happening? Here the moment when I apply here A equal to 0 and then B equal to 0, what is happening, sir? Here automatically the moment when I apply both are zeros, here both switches are turns off, which means here the switches are open, we can say. Both switches are open. The moment when both switches are open, there is no connection between this node and output node. Input node and output node, there is no connection, and there is no possibility that this 5 volts power supply will go to this output, or we can say that bulb. So output will be, we can say 0, Y will be 0, and then bulb will be off state. Off state. And now let us take second condition here, A equal to 0 and then B equal to 1. Sir, what will happen? The moment when I apply A equal to 0 and then B equal to 1, here because A equal to 0, the S1 switch will be open, and now here because B equal to 1, we can say that the switch will be connected. Here the switch will be closed. Sir, though the switch B will be closed, here A is open, so that there is no connection in between input node and then output node, because there is a switch A and which is open state, so that there is no connection established between input node and then output node. Then there is no possibility that this 5 volts power supply will go to output and then bulb, so that output is 0 and then again bulb will be off state. And now coming to third case, here A equal to 1, we can say A equal to 1 and then B equal to 0 case. What will happen, sir? Here because A equal to 1, we can say that there is a connection established between input node and then output node. But coming to B here, sir, because B is 0, here the switch will be opens. So now what will happen, sir? Here the whatever we apply 5 volts power supply, it will go to up to B, and there is no connection between this input node and output node, and there is no possibility that this 5 volts will go to output Y and then bulb. Again we can say that here the S1 will be open, close, of course, close, and because S2 is open, output is again 0 and then bulb will be again off. And now coming to the final case, we can say, sir, here the final case A equal to 1 and then B equal to 1. The moment when we apply A equal to 1 and then B equal to 1, here sir there is a connection between input and then output node. And now again here there is a connection between input and output. We can say that both switches are turns off. Fourth case, when A equal to 1, B equal to 1, sir both switches are closed. We can say that here both the switches are closed. And because the both switches are closed, whatever the power supply we are applying here, the 5 volts will go to output Y. We can say that output will be 1, we can say. And now because the 5 volts power supply is coming to output Y and then it will automatically coming to bulb, we can say that bulb will be turns on. So this is the truth table. Based upon truth table, here we can say the moment when we apply 0, 0, output is 0. When we apply 0, 1, output is 0. And then when we apply 1, 0, output is 0. When we apply 1, 1, we can say output is 1. This is called, it is satisfying. We can say that this switch circuit action is satisfying the basic truth table of AND gate. Based upon this analysis, we can say that this is called switch circuit AND gate. Now let us try to understand one more gate called OR gate. Sir, we have seen how a switch circuit is acting as a NOT gate and how a switch circuit is acting as AND gate. Now let us try to understand how a switch circuit is acting as OR gate even. Sir, here third case switching circuit act as OR gate. So the moment when we dealing about OR gate, we know the logical expression, or we can say logic gate. This is OR gate. A, B are the inputs. We can say Y equal to A plus B is output. We know even truth table here A, B and then Y equal to A plus B. Here 0, 0, 0, 1 and then 1, 0, 1, 1 are the inputs, and we can say 0, 1, 1, 1. This is the truth table of OR gate. We have seen in the previous lecture even. So this is the basic truth table of OR gate, and now let us try to understand how a switch circuit is satisfying basic truth table of OR gate. Here sir, let me take one switch circuit. Here I would like to connect one 5 volts plus 5 volts power supply. Here sir, let me connect these two switches in parallel. This is what switch 1 we can say S1, and let me take another switch here parallel to switch 1 S2. These are the two switches I would like to connect parallel to each other, and then here I would like to take output Y. From here I want to connect one bulb. Sir, bulb second and to here negative power supply negative, I would like to connect to ground. Sir, this is the switch circuit of OR gate. Now let us try to understand. Let me draw a truth table here. Sir, I can say that this is A and then input B. Here we have two inputs A and B, and now let us see what is the condition of S1, switch 1 and then switch 2, and now what is the condition of output Y, and then finally what is the situation of bulb, we can say bulb. Now sir, the moment when we take here A equal to 0 and then B equal to 0, what will happen? Sir, here the moment when we apply A equal to 0 and then B equal to 0, which means the moment when we apply A equal to 0, here switch S1 is automatically opens. We can say that there is no connection established in between these two nodes, because here the applied input is 0, and now here B equal to 0. So because we are applying B equal to 0, we can say that there is no connection established between these two nodes. We can say that here the switch will be open state, which means we can say that here S1 will be open because A equal to 0, and then S2 will be open because B is also equal to 0. And now the moment when A equal to 0 and then B equal to 0, then we can say that there is no established connection between these two nodes, input node and then output node. Because there is no connection between input and then output, here the plus 5 volts power supply is not able to reach to output Y, so that the bulb will be automatically turns off because there is no input power supply to the bulb. And now we can say that here the 5 volts power supply is not able to reach to output. We can say Y equal to 0, and then bulb state will be, here we can say off state. Here Y equal to 0 we can say. And now the second case I would like to take here A equal to 0 and then B equal to 1. What will happen, sir? Here A equal to 0 and now here B equal to 1. Now let us try to understand. Sir, the moment when we apply here A equal to 0, again here there is no connection between input and then output. Here switch is again opens because here applied input A is 0, so that S will be open again. And now coming to here B equal to 1, which means there is an established connection, we can say. There is an established connection between input node and then output node. Because of this established connection between input and then output, here the applied power supply 5 volts will be going through S2 to Y we can say output. Here from 5 volts to, we can say here the power supply will go to here up to this place. Because there is no connection, this will be the power supply will come here towards this S2 switch, and then here there is a connection through this connection, and then it will reach to output Y. So because it is reaching to output Y, we can say that here the second case output will be 1, and now here the output is 1, and then the power supply will go to bulb, and then automatically bulb will be turns on. Here sir, S2 switch will be closed, and then Y will be 1, and then bulb will be on. This is second case. And now let me take sir here third case, A equal to 0 and then B equal to, here A equal to 1 and then B equal to 0 case. What will happen? Here when we apply A equal to 1 and then B equal to 0. Sir, as like similar case, here when we apply A equal to 1, what will happen, sir? Here the connection will be established between input and output. Here because B equal to 0, here S2 will be open. Now here S1 will be closed, and then S2 will be open automatically. And now here the moment when we apply A equal to 1, sir, can we say that here the 5 volts power supply is going through S1 to output towards output Y? Yes sir. Here the 5 volts power supply is passing through S1 and then it is reaching to output Y, we can say. Because B equal to 0, S2 is open case. Sir, now here the output is 1, we can say, and now because the output is 1, we can say bulb is automatically turns on. And now the final case here, sir, A equal to 1 and then B equal to 1. The moment when we apply A equal to 1 and then B equal to 1, here we can say both switches are turns on. We can say both switches are closed state, we can say both switches are closed, so that the applied 5 volts power supply will be divided here, and then it will go through S1 and then it will automatically go through S2, and then finally here at this particular output node the power supply will be again added, and then it will be forward towards Y1. So we can say that output will be Y1, and then because the output is Y1, we can say that bulb is automatically turns on, we can say. See here, sir, output is Y1 and then bulb is automatically turns on. Sir, this is the truth table, or we can say analysis table for the OR gate switching circuit condition. Now let us try to understand here when we compare these both basic truth table and then switching circuit truth table. When we apply input 0 0, output is 0. Here when we apply input 0, output is 0. When we apply 0 1, output is 1. And then here for all three cases, when we apply 0 1 1 0 1 1, we can say that output is 1. Here also similarly when we apply 0 1 1 0 1 1 case, we are getting output as 1. So that here this particular circuit, when we apply switch S1 and S2 in parallel to each other and in series with bulb circuit, we can say that the circuit is acting as OR gate. Now let us try to understand how a NAND gate acting as switch circuit, or we can say what is the switch circuit for NAND gate and what is the switch circuit for NOR gate. Let us try to understand. Sir, now based upon the knowledge up to what we have seen, now let us try to understand what is the switching circuit for NAND gate. Sir, here this is a fourth case. This is a fourth case switching circuit, or we can say NAND gate acting as switch circuit. Let us try to analyze this case also even. Sir, here we know that the NAND gate here this is a NAND gate, we can say that here this is a NAND gate. We know that y equal to a into b whole bar, and then truth table a b, y we can say 0 0 0 1 and then 1 0 1 1 case. For this particular inputs we are getting output 1 1 1 0. It is exactly opposite to AND gate we have seen in the already previous lectures when we are learning about gates, logic gates. So now let us try to understand how a switch circuit is acting as a NAND gate. Sir, what type of switch circuit we just need to take? Let us see. Here I want to take one power supply. Here this is a plus 5 volts power supply similar to previous circuit. Here I want to connect here the switch 1 S1, we can say S1, and then switch S2 we can say here switch S2. Both switches are I'm connecting in parallel to the bulb, we can say that. In the previous lecture when we are learning about AND gate, OR gate, we are just connecting these two switches to in series with the bulb, but now I'm connecting these two switches in parallel to, or we can say in parallel to bulb. So here input A and then here input B, I'm taking output, we can say Y here. Sir, what is the analysis? Now let us try to understand. Here I want to take A and B are the inputs, and now this is the S1 and S2, we can say output Y, finally bulb B we can say. Sir, the moment when I take 0 0 are the inputs, what will happen? Here the moment when I take B, A equal to 0, B equal to 0, we know that A equal to 0, B equal to 0, automatically both the switches are open state. Here also, this is also open state. The moment when both switches are in open state, what will happen, sir? The applied 5 volts power supply will automatically go to output Y, because there is no connection established between input and then ground. Here because both switches S1 and S2 are open, here there is no connection in between here S1 node and then ground node. The power supply will not come to ground and it will reach to output Y. We can say output is 1, because output is Y, automatically the bulb will be turns on, we can say. And now the second case, sir, here A equal to 0 and then B equal to 1. What will happen? Here A equal to 0 and then B equal to 1. Sir, here B will be short circuited and then A will be open circuited. Though B is short circuited because A is open, there is no connection between S1 and then ground. Because there is no connection between S1 and then ground, here the applied 5 volts power supply will go to Y. We can say that here A is open and then here B is closed. Even then the output is 1 and then bulb will be turns on. Let us try to take third case. Here A equal to 1 and then B equal to 0. What will happen, sir? Here A equal to 1 and then B equal to 0. When we apply like this, even here A equal to 1, because here the circuit is short circuited, and B equal to 0, we can say B is open circuited. Again there is no connection between here input and then ground. Because there is no connection between input and ground, here the applied power supply will again go to output, we can say Y. Now here S1 is closed and then here S2 will be open. Now the output is 1, and because output is 1, we can say bulb is automatically turns on. And then the final case, let us try to take here A equal to 1 and then B equal to 1. Both the inputs are high. We can say that here both switches S1 and S2 also short circuited. There is an established connection between here input node and then output node, we can say. Here there is a connection. Because there is a connection between S1 and then ground, we can say here the applied power supply will automatically go to ground, but it is not going to output. Why it is not going to output? Because sir, here we are placing one bulb. Before bulb we are just placing one resistor circuit to protect this bulb. So because of the resistor bulb, here there is a restriction for the flow of electrons. Because of the restriction, here automatically the power will be going to free path. Here in this particular path there is no resistor at all. Here there is no restriction for the flow of electrons. So that is the reason, because here the applied 5 volts power supply will go to S1 and then S2 and finally it will reach to ground. And then there is no power supply to Y. So here the output is 0. Because output is 0, bulb is automatically turns off. Here S1 is close, and then S2 is also, we can say, close. Then output is 0. The finally we can say bulb is, we can say, off state. Bulb is off state. This is what the truth table of NAND gate. Sir, let us try to compare the basic truth table and then switching circuit truth table. Here the both truth tables are same, so that we can say that this particular switching circuit is acting as NAND gate when we connect these switches S1 and S2 in parallel to the bulb. Sir, this is what NAND gate. Sir, up to now we have seen 4 types of switching circuit analysis. Now let us try to understand the last case. We can say that NOR gate switch circuit analysis. Here NOR gate switch circuit analysis, the 5th case, we can say NOR gate acting as NOR gate. Sir, we know that this is a NOR gate. This is a NOR gate. Here A, B are the inputs. Y equal to A plus B whole bar. We know the truth table of NOR gate here. Let us see how the truth table A and then B, we can say Y, 0 0 0 1 1 0 and then 1 1. We can say that here Y equal to, we can say this is 1 and then all remaining are 0 for NOR gate. Sir, this is the basic truth table. Now let us try to take one switch circuit here. One switch circuit. Based upon this switch circuit analysis, let us try to understand how this circuit is acting as NOR gate. Sir, as like NAND gate, I would like to connect here 2 switches S1 and then S2 in parallel to each other. Here I can say S1 and then this is S2. I would like to connect these 2 switches in parallel to each other, and then finally I want to connect one bulb here. This bulb will be parallel to both the switches. I would like to take output Y. Sir, here we can say this is ground and then this is plus 5 volts power supply. Here A input and then B input. Now let us try to understand the analysis. This is bulb, and now here this is A, B, the switch circuit S1 and then S2 and then output Y, finally bulb. The moment when I take A equal to 0 and then B equal to 0, what will happen? Here A equal to 0 and then B equal to 0, A equal to 0, B equal to 0. Because both the inputs are 0, there is no connection between input and ground. Here the complete entire power supply will go to output, we can say. Here both the switches are open. Here the power supply may come to up to this node, but it will not reach to ground, so that the entire power supply will go to output. We can say output Y equal to 1, and then it will be, bulb will be automatically turns on. Both are open here, S1 and then S2 are open. Y equal to 1, bulb will be on, we can say. And now the moment when I take 0 1, what will happen? Here A equal to 0 and then B equal to 1. Sir, here A may be open but B is short circuited because B equal to 1. Here S1 is open and then S2 will be closed. Because S2 is closed, the entire power supply is going through to ground through S2, we can say. Here the entire power supply is reaching to ground through S2. Here, because I told you in the previous lecture even, here there is a resistor circuit we are placing here to protect this bulb. Because of that particular resistor circuit, the entire power supply will be restricted somehow, so that the power supply will be going through free path. We can say that there is no resistor circuit in this particular path. Here the entire power supply going to ground through S2, we can say. Here, so that here the entire power supply is reaching to ground, we can say output Y equal to 0, bulb will be automatically off. And now third case we can say 1 0. The moment when I take S1 equal to 1, we can say S1 is short circuited and then S2 will be open circuited. We can say S1 will be closed and then S2 will be open, we can say. Because S1 is closed, so the entire power supply is going to ground through S1, we can say. And now output Y equal to 0 and then bulb will be automatically off state. And now the fourth case, A equal to 1 and then B equal to 1. Here the moment both circuits, we can say both switches are short circuited, which means S1 is closed and then S2 is automatically closed. The moment when both switches are closed, automatically the entire power supply will be reaching to ground through S1 and then S2. So there is no power supply is going to Y, we can say output. So output will be 0 and then the bulb will be automatically off. This is what the truth table of NOR gate. Now if you can compare the basic truth table and switching circuit truth table, both the truth tables are similar. Now based upon this analysis, we can say that this particular switching circuit is acting as NOR gate. This is what the analysis of switching circuits in Boolean algebra. Thanks for watching. Please do subscribe.